hopefully today's lesson will be pretty easy. We've already talked about slope-intercept form. So slope-intercept, that does not look like an I. Intercept form of a line, y equals mx plus b. Probably the most common way of graphing lines where m's the slope, b's the y-intercept. But today we're going to talk about a form called standard form. We're going to work our way up to it. So first, let's review how to graph horizontal and vertical lines. Remember, y equals -3 would just be a horizontal line. So that's really crooked. Running through the y-axis at -3. And remember, the reason why is no matter what point I pick on that line, the y value is always -3. That's what they all have in common. The x could be anything. Like right here, maybe is, whoops, is it on draw? What's it doing? Pen's all messed up. There it goes. So like that point maybe is at -2.5, but it's still down 3. They all have a y value -3. And then x equals 2, that's just a vertical line running through the x-axis at 2. For the same reason that the equation is what it is, because no matter where I pick on that line, oops, my x value is going to be 2. You know, like way up here is going to be the 0.2 of 1,000 or something, you know, like, but they're all, the x is 2. Now, what if we look for our x and y intercepts on here? So right here, y-intercept just means the point where you cross the y-axis. Well, that point right there is at 0, -3. And the x-intercept on this one is at 2, 0. So for our first one, the first two examples, an x-intercept was here. A y-intercept was here. Let's see what happened. The x-intercept, whenever you cross an x-axis, we've already talked about this. The one thing you know for sure is there's some x value sitting there, but the y value is 0. If it's over here, there's some x value sitting there. Maybe it's at x of 1, x of 2. Y value 0. If you're crossing a y-axis, I don't know what the y value is, but I know the x value is 0 because I'm not going sideways any. So for an x-intercept, there's some x value and then a 0 for y. For a y-intercept, there's some y value and a 0 for x. And that's all this says. It's just the synopsis from the book, where if they say your y-intercept's b and your x-intercept's a, then the x-intercept's at a0, the y-intercept's at 0b. But here's the whole key to it. An x-intercept, if you want to know where it happens, you let y equal 0. If you want a y-intercept, you'll let x equal 0. That really doesn't like an x. Let's fix that. And when we write the equation of a line in this form, like let's say some number x plus some number b, well, let me rephrase that. Some number times x plus some number times y, there we go, I was saying the b, is equal to some number. Like the a, b, and c all stand for constants. The x and y are your variables. We call that standard form. And it's really handy. What standard form is best for is to graph lines using the intercepts. Okay, so let's do some. So the first one we're going to do, 3x plus 4y is 12. Okay, what if I let the x equal 0? Okay, so if I let x equal 0, this part right here just disappears because it'd say 3 times 0 plus 4y is 12. It would leave me with 4y being 12, so y would be 3. So if I let x be 0, if I have 0 as my input, 3 is my output. Okay, over 0, up 3. I just found a y-intercept. If I let y equal 0, then this part disappears because it'd say 3x plus 4 times 0 is 12. Well, that's just saying 3x is 12. So x is 4. So on the x-axis, 1, 2, 3, 4. I'm going to go to x is 4 and put a point. And how many points do you need to make a line? 2 different ones. That's all you need. That's 2 distinct points. And so I could sit here and I can see the pattern. Like to get from that first point I drew, the y-intercept to the x-intercept, I had to go down 3 and over 4. So I could line the rest of the points up. I'm going to change color. So the black ones are the ones that are the intercepts. But I could keep going. Down 3, right 4. Oops. Or I could go up 3 and back 4. Up 3 and back 4. And then all these line up, and there's my line. Now let's compare that to what would have happened if I'd done this with slope-intercept form, where I just rearrange it, divide both sides by 4. Y-intercept 3, down 3 over 4. It's the exact same line. It's just a little bit quicker if we just graph it using those intercepts. Okay, so same thing here. If I let, I wish my pen would quit acting up. Okay, so for part B, if I still doing it, what is going on? There it comes. If I let x be 0, then this part's just going to disappear. I'm going to be left with negative 2y is negative 20. So y is 10. So if I let x be 0, x is the input, 10 is the output. If I let the y be 0, then I'm going to be left with 5x is negative 20, and x is negative 4. So 0, 10 is my y-intercept. Negative 4, 0 is my x-intercept. And then I've got my line. And I went from, say, this point that's over here towards the left, I went right 4 and up 10. So I could go down 10, 1, 2, 3, 4, and back 4 if I wanted to line up another point. Now, once you think about this, what does that make the slope? The slope's a positive rise of 10, run of 4. So the slope of this thing is positive 5 halves. So if I rise 5, 1, 2, 3, 4, 5, run 2, I should have a point right there. Or if I go down 5, 1, 2, 3, 4, 5, and back 2, I should have a point right there. So, oh, look at me. I freehanded that pretty well. Okay, so this one, same deal. If I let x be 0, I'm going to be left with negative 4y is 8. So y is negative 2. So there's my x-intercept, 0, negative 2. If I let the y be 0, I'm going to have a 2x equals 8. So x is 4. There's my x-intercept. So I've got a y-intercept of negative 2. 1, 2. An x-intercept of 4. And look, to get from one to the next, up 2 over 4. Up 2 over 4. Or I can go down 2, 1, 2, 3, back 4. Down 2, 1, 2, 3, back 4. There's that line. Okay, so positive slope. I rose 2, ran 4. But remember, that just reduces to a half. So I could have gone over 1, up 1 over 2, up 1 over 2, up 1 over 2. I got to get a little bit off right there. Or down 1, back 2, down 1, back 2, down 1, back 2, down 1, back 2. So I could continue. Okay, now this one, let's say I let x be 0. Then 12y is 24, y is 2. Okay, I got a perfectly good y-intercept. If I let the y be 0, I'm going to get negative 16x is 24. So x is negative 24 over 16. Both of those will divide by 8. So negative 3 halves. So that does not affect what my x and y intercepts are. I still have them. 0, 2. And then negative 3 halves is negative 1 1/2. So there is a y-intercept right there. But this is one where, let me show you the directions. It said, if the intercepts are not lattice points, convert it into slope-intercept form and graph using the y-intercept and the slope. What lattice points are is when, like these other 3 examples, 0, 3, 4, 0, 0, 10, negative 4, 0, 0, negative 2, 4, 0. where every single coordinate in those points or in those ordered pairs is an integer. Okay, well, if we have a rational number that's not an integer, it's like a fraction, we may not want to do that. So let's just go back to what we learned how to do on Friday. If you've got negative 16x plus 12y is 24. And you know y equals mx plus b is what, if we could make it like that, divide both sides by 12. We know how easy this would be. That gets me 16/12 x plus 24/12. Well, 24/12 is 2. 24 divided by 12. 16 and 12 both divided by 4. That's 4/3 x. So I've got a y-intercept 2 still. I could rise 4. 1, 2, 3, 4. Oops. Ugh, I don't know what the computer's doing. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. See how it still went through there? 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. Sounds like I'm counting off some dance. So even though it is really simple to graph lines using their intercepts, sometimes it's a little bit more simpler just to use slope-intercept. So it's good to have both of those skills in your pocket so that you can use whichever one's the easiest. Okay,